So I had a very insightful friend who told me 25 years ago, he said, Ashish, in 25 years, there will be no newspapers and print media, which is turning out to be close to true. And there will be self-driving flying cars. So the flying bit we don't know yet about, but certainly the self-driving cars are turning into a reality. And what has really made this a reality is the advancements in the compute power that is available today and the amount of data that can be harnessed and analyzed. And that is really what has caused the resurgence of AI in the last 2 to 3 years. So today we have a great set of panel where 3 experts are going to share their perspectives on AI with you. And then we'll have a discussion and we'll open it up to some of your questions and participation so we can really nail this issue of AI, especially for you as investors in these days of very fast-moving technology. So without diving too much into the details and not stealing their thunder, let me introduce our first speaker to you. Handol Kim said AI before he said mama when he was 2. So Handol has been instrumental in the field of AI for a long, long time, first with D-Wave and now his own company, Variational AI. He's also the vice chair of AInBC, which is truly bringing the momentum of AI and putting BC on the world map when it comes to AI-related technologies and startups. So let's hear from Handol on what the AI scene looks like here.
Thank you, Ashish. Wow. How's everyone doing? All right, mama. Just a show of hands, who here is an investor, an angel? All right. And of you, how many people feel comfortable being able to do due diligence on AI deals? Okay, all right. Okay, so what we're going to do today is talk a bit about AI, the landscape here in British Columbia, go through some of the assumptions, a little quick, really back of the napkin sort of tutorial, and then a cheat sheet on some questions that you can ask potential entrepreneurs that you want to invest in to see if they actually know what they're talking about. The idea here is, as investors in especially angel investors, you play a very critical role in the ecosystem of enabling the next generation of startups in British Columbia to become successful. And if you feel that you are not capable of doing due diligence on AI companies, well, that's a problem. And that's something that we'd like to try and fix. Yeah, please. Okay, so as Ashish said, I am vice chair of AInBC. We're the AI network of British Columbia, and we are an industry association and community organization trying to foster the development of AI companies here in British Columbia. And so, that's okay. And, well, that was going to be at the end. I was going to ruthlessly plug myself, but there we go. Okay. So what we're going to talk about today is the objective is to provide you with a landscape of what BC AI companies are strong at, some information about how to do some diligence on them, and then eventually have you try to invest more money in the ecosystem. So, yeah. Okay, great. Thank you. Sorry, it's a PDF. Okay. Oh, yeah, thanks. Okay, so I'll talk about the objectives, assumptions. You've heard AI, you've heard machine learning, you've heard deep learning. What's that all about? I'll go through it very quickly. Also a sort of cheat sheet in terms of how to, or a really quick sort of litmus test in how to determine the difference between AI and machine learning. Where is BC strong in AI, and a checklist of questions, and then how you can help. And we'll call to action at the end for all you marketing people. So I'm going to assume several things here of the audience. One is that you invest mainly in local companies, and that you're not AI machine learning experts. If there are any of you who are in the audience who know machine learning, then you will forgive me in terms of being somewhat factually inaccurate in order to make it accessible. All right. That I'm also going to assume that you don't have a lot of time to do deep technical due diligence on your potential investments, but that you're savvy investors. Okay. So AI, machine learning, deep learning. You've heard these terms used and often used interchangeably. What the heck is it? All right. So here's a really simple thing to remember. We talk about AI. Usually, it's a descriptor of a sector. Right. It's not related to specifically the technology of AI, because AI is a distinct technology, otherwise known as artificial general intelligence. There is machine learning, and then deep learning is a subset of machine learning. But forget all that. When we talk about AI, we're talking about the sector in general. For example, we talk about semiconductors, or we talk about wireless as a sector, not necessarily as the technology descriptor. Okay. The thing to remember, though, is there are gradations of machine learning and AI, in the sense that, very roughly speaking, a rule of thumb is the lower you go down in deep learning, the more data you generally need in order to train your models. A very good functional description of what machine learning is from Tom Mitchell from Carnegie Mellon. I think he has a very elegant description, which is essentially it's software. It's a computer program that is said to learn from experience, some class of task, measured by a performance measure. And its performance in T gets better, measured by P gets better with experience. So essentially, it's software where you don't need to explicitly program something, but it gets better as it does it more often. And usually, it learns by getting more data. Okay, still with me? All right. Or really simply, the difference between AI and ML is if it's machine learning, it's in Python. If it's AI, it's in PowerPoint. That's usually a very indicative sort of question to ask your entrepreneurs. Okay. Where we are in terms of AI in British Columbia, I'm sure you've all read the news that Canada is a powerhouse in AI, right? We're all aware of that. Canada punches well above its weight globally when it comes to AI, primarily because of the research that's been carried out in the last 20 or 30 years, funded by government, CFAR, various other organizations. The fact that we have Geoffrey Hinton, sort of the father of deep learning, and Yoshua Bengio in Montreal, and Rich Sutton in Edmonton, the father of reinforcement learning. Okay, but the question is where do we fit in BC in AI? Okay, and it's a legitimate question. In fact, a lot of people in British Columbia don't even believe that there is an AI industry in British Columbia. Okay, or they defecate on it from a great height, saying that we don't have quality companies in AI. All right. The fact of the matter is Vancouver has the second largest number of AI startups in Canada after only Toronto. All right. Do you know that? About 150 companies. Not only that, so that's basically the same number of companies doing AI as in gaming. All right. Now, AI companies generally hire fewer people, but it's still a much newer business. And as you'll notice, very important, as you fund these companies, the salaries are a lot higher. Okay? But the fact of the matter is British Columbia already has a very good, strong, dynamic, and robust ecosystem of AI startups. And if you're not investing in this space, then you really need to shake a leg and get involved. Where we are in terms of segmentation is if we're assuming that you're investing locally in British Columbia companies in the space of AI, then what you really want to focus on is in the areas of computer vision, visual computing, or applied AI. While we have tremendous strength in other areas, artificial general intelligence, robotics, etc., in areas of discrete logic, symbolic logic, and various other areas, by and large, these are going to be very, very technical and probably will need to stay in the lab a lot longer before they come to you for angel funding. Okay? But for you, your main requirement is to try and make a return on investment. So when we talk about that, we talk about applied AI versus core AI. And applied AI is simply AI solving for X. AI for fintech, AI for banking, AI for medical, okay? It's a company that uses AI to solve a specific problem. Okay, if they say we're core AI, we have these great AI algorithms that can solve a million different problems, then unless you have a PhD in computer science or can get time from Frank Wood or some other people who can do the due diligence, you should probably stay away. All right, that's going to be more in the purview of funding organizations that are more proficient at deep tech. But as angel investors, you want to benefit from AI in the employment of solving a specific problem that you understand. Okay, and in these areas, probably locally, you want to focus in areas related to computer vision, right? That includes medical imaging, that includes surveillance, that includes facial recognition, that includes various types of AI that is used to do visual computing. You also probably want to look at robotics simply because for some strange reason in Vancouver we've got a lot of really good robotics AI companies. All right, and that's potentially very disruptive. FinTech and banking, that's another area where we're doing really well in BC. And then finally in digital and MarTech, right? Anyone using AI to basically do recommender systems for e-commerce, for content syndication, for marketing technology, various other spaces related to this are also ripe areas for Vancouver and British Columbia AI companies. All right, so why? One of the issues is that you get a lot of companies saying they use AI and they don't. All right. As investors, you have to be very wary of this, right? There's a very off-cited statistic that 40% of AI companies in Europe don't actually use AI. All right. But why? Why would you claim that you use AI when you don't? Well, it's because you can get more money. And often, sometimes you as investors, because you want to appear smart, you go like, oh, are you guys using AI? And so the entrepreneur feels compelled to say that they have an AI story when they don't, okay? AI is a great technology in certain cases where it works. Where it doesn't, it shouldn't be used. Just because a couple of companies are using AI to solve a specific problem doesn't mean the entire space should, okay? So we have to be a bit nuanced in terms of what AI can and can't do. But basically, if you are faced with an entrepreneur that is trying to raise money for their AI startup, there are some really simple questions that you can ask, all right? One is, what is the problem being solved by AI or machine learning, right? What is the problem? Is it in the space of classification or regression, right? If they can't answer the question from a machine learning perspective or a mathematical or computer science perspective, then they probably don't know why they're using AI. They're probably just using AI because that's what investors are looking for, okay? The next thing is, the problem that they're solving, is there enough data for them to employ a machine learning model to solve this, right? We are now in the space of supervised learning. I'm going to make an assumption here that most of the entrepreneurs that are going to come to you are in the area of supervised learning, which means there's a lot of data that people use to train a model so that you can predict on new data. That's really all machine learning is, all right? So the question is when they train their model to make predictions, whether it's like, if this person buys X, are they going to buy Y? Is there enough data to train a model that does really well? Okay. If there isn't, then how are they going to get enough data? Okay. Then they have to use different forms of more advanced machine learning, and that puts you into territory where they're doing more R&D. The data that they use to train the model, known as the training set, is it representative of the population? Okay. So if I'm trying to find out if people will go to, link A, B, or C, okay, and my training set has all three of these links, but then there are 3 other links and my training set doesn't have them in it, I'm not training a model that's going to be representative of the population of choices, okay? All right, so you need to make sure that the training set represents the population of the choices that people are trying to generalize against. The data set that they use to train, where is it from? Right? You've got a training set, you're trying to train a model, where's it from? Oh, we use YOLO, Inception, VCC, all of these publicly available models, right? Oh, this stuff is, we go through PubMed and we take all of this stuff and, all right, usually that's not going to be good enough, okay? If, depending on the use case, what you want are people who are able to take existing models, but also incorporate other models that may be proprietary, especially in the enterprise and B2B space. A lot of the companies have proprietary data that is potentially much more valuable than the stuff that's out there, in the public domain, usually, right? The next question is the data labeled? Does anyone understand what labeled data means? Okay, yeah. Give you an example. You have a CT scan of a lung, right? So someone has drawn a box and said cancer or no cancer, right? But if you just have that scan and there's no box and there's no label saying cancer or no cancer, that's unlabeled, right? Then you need a completely different type of AI in order to do that. And that's tougher, okay? So you want to make sure that when you have data that trains the model, is it labeled? Usually in terms of MarTech and digital technologies, it's already taken care of for you. But in the area of computer vision and visual computing, this is very important. Next, do you trust the labels, right? It could be that you have 20 people labeling the data, maybe 10 of them are really bad, and they mislabel stuff. The model will learn that. You need to trust your data. You need to trust your labels. Who developed the algorithm? Did someone read a paper or did they just download it off of TensorFlow and then put the model to work? Okay, these things are very important to understand. What is the provenance of the data? Where's the algorithm from? What kind of work was done to tune the algorithm for the specific problem that your company is trying to solve? How well does the model perform? Oh, we get 90% accuracy. That sounds really good, but in some cases, that's really, really bad performance. And understand also, to go from 90% to 99% is a logarithmic exercise in effort, all right? And go from 99 to 99%, 99.9%, that's similarly tough, okay? At a certain point, you get diminishing returns, all right? So you have to understand how good is good enough for a commercial problem. We worked on a project with a customer that was in the area of surveillance. They were getting a lot of false positives because these cameras were seeing moths at night, right? And this would happen 100 times each night. And we took them from a very high percentage to an even higher percentage, but it still resulted in 20 alerts going to the people each night, and that's not acceptable. So even though we had managed to advance the state of the art and publish papers, academically this is significant, business-wise, who cares? All right? So that's very important for you to understand. And finally, do they own their own GPUs? If someone says, you might be in the space of IoT or inference, but if you don't own your own GPUs, you're probably going to go bankrupt. If they say, oh, we use Google to train our models, run away, because they don't know what they're doing. Or they're going to take all your money and give it to Google, and Google's rich enough, or Amazon. Okay. So, sorry, the takeaway here is, if the answers to most of these questions are positive, like yes, then you know what? The machine learning and AI is not that advanced. It's not a technical barrier to entry, which is not necessarily a bad thing. It depends on the problem that your entrepreneurs are trying to solve. If the answers to these questions are negative, then it's a really hard machine learning problem, and you better have people who know what they're doing. And who are the types of people that know what they're doing? So we see this also being used interchangeably. We see data engineers, data scientists, machine learning engineers, machine learning researchers. They're not all the same thing, okay? A very simple analog to think about is a data engineer is like a paramedic, right? It's generally a software engineer who's taken a few courses on Coursera and knows a bit about this and that, and they get paid a lot more money. Good for them, all right? We need people like this, okay? But they're not the kinds of people who can develop novel algorithms. A machine learning engineer is kind of like a nurse, primary care provider, right? They know what they're doing. They know how to deal with the data. They know how to do models. They know how to do things. But again, they're probably not the person who's going to come up with a treatment plan, okay? Then you have a data scientist, and a data scientist is a doctor. It's an MD. But they're a general practitioner. They see all sorts of different problems. Machine learning is one tool that they would use, but they're not going to specialize in machine learning, all right? So it's true that general practitioners of medicine can also do research, and they're also trained medical physicians, okay? But their primary thing is to do treatment, okay? So they're working with the data. A machine learning researcher is going to be a PhD in computer science or some related field that does novel research algorithmically and in applied mathematics, okay? That is a neurosurgeon. It doesn't mean that they're better. It's just if you have a neurosurgical problem, you want to go to a neurosurgeon. You don't want to go see a GP, right? So understand what the definitions are and understand what the differences are. If people say we have the most advanced machine learning in the world, we've got 100 data scientists, yeah, probably not, okay? So how to help? Don't be afraid of investing in AI. Hopefully this has not scared you. And I hope that you can use this information to invest in companies, such as Sidewalk AI or Amanda AI or some of these other companies that are going to be presenting, because we need your money, we need your help, we need you to be smart, and we need your support in order to build a robust and dynamic ecosystem of AI startups in British Columbia. Join AInBC. We'd love to have you. We're a not-for-profit organization. We're at AInBC.ai. And please, it's data, not data. It's a pet peeve of mine, right? But honestly, if you say data is like an early 20th century, artistic movement founded on like absurdism, okay? Data, all right? We're not selling cell phone plans. We're doing data science. We're doing machine learning. So it's just a pet peeve. All right, so thank you very much.
Thanks, Handel, for that amazing introduction to AI. Now I know when to go to a neurosurgeon versus a GP. Thank you for that. The next speaker is going to give you a perspective from a growth perspective. Ran Rumianek handles AI and growth for Change Healthcare, a $3 billion healthcare IT company with offices local in Richmond. It's an American company, and the local business is in medical imaging. And my interest in Ran's topic was to understand how do big companies think about partnering with smaller companies in terms of AI and growth of small companies. These large companies cannot solve all their problems, and so they do need help. And a startup ecosystem really goes a long way in solving some of these problems collaboratively. So let's hear from Ran on his perspectives on a large company AI view.
Thank you, Ashish. And one of the privileges or benefits of working in the past with Ashish, that he is one of the only guys that can really pronounce my last name properly. So, so yes, like as Ashish mentioned, I'm leading AI and the artificial intelligence for Change Healthcare. In this role, I'm overseeing both like our overall strategy, our internal AI development with our data science group, as well as the work with this large AI ecosystem startups around medical imaging. And we work together to build better AI-enabled solution. And what I want to share with you today is really some insights that I'm having working with many of those startups on what really could make the difference between a startup that really makes great algorithms to the one that can really translate it into commercial success and happy and hopefully paying customers. So about Change Healthcare a little bit, like as Ashish mentioned, one of the largest digital health companies in North America, touching almost every point of healthcare continuum, from solutions to insurance providers, to clinical solutions to providers that help diagnosis and touch the patient, to patient-facing solutions that helps patient get better choices and decisions. And in the medical imaging business that I'm part of, we are developing solutions for medical imaging specialists, mainly radiologists and cardiologists, to manage the entire diagnostic process. For a radiologist, for example, our solution is like their homepage. They're using it like 10 hours a day, our solution, or if they made a bad choice, one of our competitors' solution. And they read about 700 million imaging studies in the US alone. To diagnose, and they use it to diagnose anything from cancer to fracture to brain bleeds to heart disease and so on. And with the development of AI, more and more investors and people will start saying, hey, we already know how to recognize automatically cats and dogs and faces. Maybe we can do the same for tumors and other diseases, and then help improve care, and maybe even replace the radiologist altogether and tap into an industry of $100 billion only in the US. So there's a lot of temptation, and some of the leaders in AI actually predicted that there will be no need for radiologists in few years. So really a lot of money was flowing into this industry, almost $1.5 billion estimation in the last years, going to over 200 startups. And on top of that, investment by companies like Google's and others. And all of these companies, some have raised kind of a couple of millions. I think the largest one got almost 500 million. Are tapping into different diseases on different types of images, on different body parts, and try to diagnose them automatically to help with different use cases. And most of these companies are not what I call solution companies. They define themselves as AI companies, meaning they're not trying to compete with us or build a new city machine, but to solve point problems. And they all want to get to our homepage and commercialize themselves through our solution in a B2B or a B2B2B type of way. And over the last 4 years, there were outstanding achievements in that area. If you can read even in the non-professional news from time to time, how Google managed to beat radiologists in better detect breast cancer, or an ophthalmologist in better detect eye diseases. And it's no longer only in research, but also in practice. The FDA has granted more and more regulatory approval for these solutions to work in a clinical environment. And finally, as you know, if not as a professional, as people that engage with the healthcare system, there is no lack of opportunities for improvement in the healthcare system. All the way, for example, using AI to better prioritize study for the radiologists, so they can look at the most urgent one first, and can, keep lower priority for the one that can wait. And we've already at Change Healthcare commercialized such a solution with integration with several AI startup companies. Or something that a lot of the company taps into is really better diagnosis, so really identify tumors or other things that can help prevent misdiagnosis. And perhaps the holy grail is really how you can connect a lot of dots together and provide a more personalized treatment and diagnosis for a patient based on multiple data points. Because most of these solutions are still more narrow AIs that helps detect very specific types of diseases. So the question is, with all this money flowing and many smart people working on these types of problems, and the healthcare industry is $3 trillion, right? And amazing technological advancement, why only handful of AI startups are really managed to translate these great algorithms into actual commercial success? I have another talk when I'm talking about the other bigger problem of the industry and why transformation is slow, but still there are a few companies that are doing well, and most of these 200 are struggling. And my insights, and again, it's not the only thing you need to do to be successful, but from my perspective, these things can make a difference. So first, and Handol was mentioning as well, the more successful companies are the ones that understand there is nothing wrong in leverage the hype around AI to create excitement and open doors and interest, but they understand that customers don't need algorithms, they need solutions, and nobody will pay for their solution long term if they don't solve a real problem for the customer. So they're obsessed about the customer, not about the AI. A good example in our domain is how, for example, an algorithm that helps the radiologist to detect a tumor in the lung, if it will add too much time for the radiologist in documentation and clicks, and false positive, he just won't use it, even if it could benefit the entire system. They're getting paid by the click. Another important thing, especially in the B2B, to remember is that those companies understand the buyers no less than they understand the users. Especially in this area, those are different entities, obviously, and they need to have a different value proposition and ROI for them. Again, another example from the healthcare domain. Many hospitals in the US, their revenue is proportional to the number of imaging procedures they do. So an AI, for example, that helps them to reduce the number of unnecessary study, it won't be a good fit for a certain type of this segment, and those companies to know that and don't know how to address the right segment. The third point is that just as an example, many of these 200 companies approach me even directly, right? And they want to be in our homepage and want us to commercialize them. And it's very hard, like Handol was saying, how accurate they are, how serious they are, do they really provide an ROI to the customer? You need to invest a lot in really understand how well they're doing. The companies that really gets our attention are the ones that say, oh, and by the way, we already partner with your hospital, and let us connect them together, and they can tell you how well of a job we've done. This is a tip that obviously is more relevant for B2B or B2B2B companies, but this could make the difference, and these are the companies that eventually ended up in our homepage and enjoy our channel of thousands of hospitals. And finally, in an enterprise sales team, again, our sales team can go different way. They have a large portfolio of solution, and sales team tend to take the path of least resistance, sell what is easy for them to sell, and they will all be happy to have AI on their portfolio to brag in a new opportunity. But if they now need to go back to a healthcare system and spend a day or two, and they're not sure if you're really reliable and it's too complicated and they don't understand the price, they will prefer to sell an upgrade. So those companies that were successful were very diligent about educating the salespeople, make their life easy, support them, and excite the customer. So when they come to the meeting, the customer is already ripe for a decision. Thank you, I'll be happy to discuss more in the panel.
Thank you, Ran, for those insights in terms of how startups can partner with some of these larger organizations and find growth. Now, we talked a little bit about the basics of AI and some of the technology, and then we talked about the growth. And the third important aspect of AI is the talent. A lot of this is new for us, and for many companies, having the access to the right talent is quite important. So our next presenter, Ian Begg, has been living at the intersection of academia, research, and industry for a long time, and fostering a collaboration where the talent pipeline can continue to be generated. And so let's hear from him on the perspective of talent in AI.
Good afternoon. Thanks very much, Ashish, and Hilza for inviting me. If you just wait a minute. There we go. I'm Ian Begg. I'm Managing Director of Innovation Partnerships at UBC. My group was set up to help with connecting investors, companies, governments with researchers at the university. There we go. And I want to really tell you three things this afternoon that can help you as investors and the startups you're working with. But before I get to that, it's probably useful to give you a sense of why my group was set up, because this is UBC's numbers. UBC is a very large university. SFU on the Hill is got a similar profile, but not quite as big. So if you want to come and work, then you need someone to guide you through. The thing I wanted to point out, huge amount of sales, but we process roughly about 2,500 research contracts with companies per annum at about $170 million. So we have a lot of research going on. In terms of the talent, and let's just focus purely on computing science here. We're looking at something like 2,000 computing science undergrads in majors in computing science, 200 plus grad students. This year we had something like 1,200 people apply for grad school listing AI or machine learning as their primary choice. Look at the next line. We took in 40. Now that says two things. One, it says there's a huge interest. Two, it says that the people that we're taking on are very, very good. And as an aside, they typically want to remain in the ecosystem here in Vancouver. There is a downside, and we're not serving everybody. You can see also some of the alumni, where they've gone, quite an impressive list. It's also worth commenting that we have professional masters at UBC. We've got data science. SFU's got big data and visual computing. These are hard programs to get into, all of them. So when you go and look at somebody coming out of these programs, you know they're going to be good. In terms of the capabilities, looking at both campuses here, both universities, as you say, as Handol had pointed out, there's a lot of visual computing, machine learning, natural language. CADA is one of the areas at UBC, which is the Center for AI and Decision and Action. We've got 20 core professors, 60 affiliate professors, 24 departments, and the focus is really on the development, analysis, and application of AI beyond what Handel described as deep learning. Why that's important, I'm going to show you now. So we talked a little bit about the talent, but the capability and the research output is, I wanted to show you two examples that show that the research has a commercial application immediately. First one is this. It's a project that's been done in conjunction with the digital supercluster here in town, and it's really looking at the behavior of the left ventricle and the heart. The actual deck has the heart pumping here, but the left ventricle is the piece of the heart that pumps the freshly fresh blood to the rest of the body. If you can see on the right-hand side here, this is a typical ultrasound view of the heart. It's very, very fuzzy. You can't tell where, if there's a problem with the left ventricle, you can't even tell where it is. So 2 researchers did a very nice piece of work, some core AI work, and some application to identify where the left ventricle is. And then the clinical experts can then use that to make decisions. The interesting thing is this is on a portable ultrasound device, and so this could be deployed around the province in very different ways. So there's a nice business opportunity here. The second example takes deep learning, but it integrates in physics, the behavior of the real world. If you look in the top left-hand corner, there are 2 images of a street scene. On the left-hand side, there are a whole bunch of dots. Those are raindrops on the front of the photo sensor. So if you've got a UAV, an unmanned vehicle, then those dots can cause the vehicle to do things incorrectly. This technology, using deep learning and physics, has removed those droplets effectively. They've also done a piece of work here where this is actually an animation of a car, and it's moving around a street, but it sees a shadow. In many cases, the vision system cannot detect whether that shadow is a shadow or whether it's an obstruction. And so it's important to be able to do that. So again, the same technologies, which is called probabilistic programming. Frank Wood is the author here, and Handol already mentioned him. Now, all these things are great, but there's a third thing that you need to be aware of, and this is where universities can really help you, and that is, where are the limitations to this? Handol had commented around the amount of training data you typically need. With large training data, you need large capabilities to be able to do this. So one of the problems expanding is that you need to be able to do it with a lot. It doesn't work with small data, most of these processes, so we need to develop techniques to do that. Again, universities can help there. With AI, there's a huge issue around privacy, regulations, policy. Imagine you've rented an automatic vehicle that is going to drive you around. If the manufacturer of that vehicle has not done a deal with a key routing provider, you may get directed in a very inefficient route to get to your location. And that's a breach of privacy. The other thing is explainable AI. You need to be able to explain why this decision is making, the AI is making these decisions. There's a really good TED talk called AI is Weirder Than You Think. And in there's an example. You all know what a tench is? Anyone know what a tench is? A tench is a game fish, about yay big. And what they did was they created an AI to try and identify fish. So they identified the fish just fine, difference in a salmon and a tench, but they wanted to find out why. When they looked at the way it worked, what they saw, and the key delineating feature was hands. Okay, so they identified the fish by looking at hands. And the reason is because the photographs were showing people holding the fish up like this. And so the hands were the key thing they focused on. So these are the sorts of things that universities can help you with. And that's all I'm going to talk until the panel. Thank you.